Now we're going to look at some limits that don't exist. There are three main reasons why a limit won't exist. The first one is that the function approaches a different number from the right than from the left. And we saw this when we were doing some of the graphical limits. It is also possible that f of x increases or decreases without bound. Now, a lot of times you will hear us say that it shoots toward positive or negative infinity. And we're not going to get too wrapped up in infinity. There's a lot of argument in the mathematical community about what it is and what it means, and so we're not going to fight that battle. The third case is the function might oscillate between two fixed values, but never approach a given value. Let's look at the first one. If I were to plot the absolute value of x over x, now here I did a graph, and you can see Wolfram Alpha didn't know what to do with this, so it just connected it with a line. Clearly, the limit as x approaches 0 of the absolute value of x over x is what? Well, if we look at it from the left, the limit as x approaches 0 from the left of the absolute value of x over x is negative 1. So if I come in from the left, I see that I'm going to get a negative 1. Now if I go from the right, it's clear graphically and from my table that the limit as x approaches 0 from the right of the absolute value of x over x is equal to positive 1. So what we say is the left limit does not equal the right limit, and therefore the limit doesn't exist. How do you put this in words? You say the limit as x approaches 0 from the right, and I'm just going to put f of x here, does not equal the limit as x approaches 0 from the left of f of x. You could have written the absolute value of x over x. That would be fine. Therefore, the limit does not exist. And yeah, you actually need to write that. The limit as x approaches 0 of the absolute value of x over x does not exist. That's how you write it. Now, let's look at another case here. In this case, the function, again, is approaching one number from the left and one number from the right. Graphically, you would look at this, you would do that diagram, and you would say the limit as x approaches, let's do negative 2 of f of x, and I can't do anything, I'm not going to write all that mess out. Well, what is that limit? If it turns out it is defined at negative 2, so if I plug in 4 minus 5 times negative 2, I get 14. So I say this one is 14. And this does not equal the limit. Let me switch colors on you. The limit as x approaches negative 2 from the right. Oh, I forgot my left side, didn't I? Well, my left side now. Okay, the limit as x approaches negative 2 from the right of f of x is 0. And you get that from the table, or you can get it from the graph. So since the limit as x approaches negative 2 from the left of f of x does not equal the limit as x approaches negative 2 from the right of f of x. Therefore, the limit as x approaches negative 2 of f of x does not exist. Now here's another case where it becomes unbounded. You can see as I come from the left, it is going and getting very, very large very fast as I approach -1. Here's my point where my function is not defined. Now, what to point something out really quick here. The function, I know, graphically shoots off to infinity at -1, but if I look at this right here, I'm going to think that it's going to have an issue at x equals 3. So you need to make sure you simplify these before you start working with them. Now, looking at this, the limit as x approaches -1 from the left is, we're going to call this positive infinity. I'm not going to really get into too much. So -1 of f of x, I don't want to rewrite all that, is plus infinity. Now, infinity is not a number. It is a representation of a concept that this is totally unbounded in a positive sense. If I look at it from the left, I can see numerically and graphically it shoots off to -infinity. So the limit as x approaches -1 from the right of f of x is -infinity. Now, I don't know why I keep forgetting my negative there. All right, so for this one, all you have to say is that it doesn't exist. You don't have to worry about the right and left. You can say it is unbounded. It does not exist. Mathematicians are terribly lazy. I'm not going to write out does not exist. I just write DNE. Now, and this is a case where I know it's going to cause confusion because it confused me when I was doing this. Let's look at what happens when x is 1. From the left, it shoots off to positive infinity. From the right, it shoots off to positive infinity. So we're tempted to say the limit as x approaches 1 of f of x is equal to positive infinity. And we will say that, by the way. But what this really means is the function becomes unbounded in the positive direction. When you approach it from the left and the right. So in this case, we're kind of treating infinity like a number, even though it's not. So the last case is always a lot of fun. Sometimes the function oscillates between two values and it never approaches 1. For example, you see this a lot when you have 1 over x shoved in somewhere, like sine of 1 over x. I went through and I did the calculation. You see I carried it out pretty far. It's positive and then it's negative and positive. And when you're coming from the left, when you're coming from the right, it's negative, negative, positive, negative. And it's never going to settle. If you were to graph this, your calculator has an absolute fit with this. So you would say the limit as x approaches 0 of sine 1 over x does not exist because, or it oscillates, and therefore it does not exist.